I'm Sandra Matheiu. I'm from Talis Alenia Space. And as you may know, Thales is a European leader for space industries. What I am challenged here today is to present you with all the current and future projects of Thales. So I can go and provide you with a list of beautiful names, but I'm pretty sure that you're going to be asleep in a few moments. So before doing that, and I'm not doing that, I propose you something different. I propose you to begin with people, to begin with user needs. Here in Thales, we are building some tools, but the tools we are building are to proceed with some users. We are here to answer the users. The users here are people that are asking something. They are asking, for example, how can I survey my sensitive area? How can I control the quality of my water? How can I see that my cities are evolving, and how can I manage it? And sometimes also some strange need that you may know here that are, how can I manage my solar plants? Here we are facing different applications, different thematics. We're talking about water quality. We're talking about cartographing and mapping land use. We're talking about atmospheric quality also. What is important to see is that to answer these kind of questions, we have in our hands tools, we have data. This data could come from different kinds of tools. They are provided by space satellites, and we have seen a lot of different and beautiful images of space. And they are coming also from in situ data and from reference data. Reference data is really important. I mean, important is not enough. It's crucial for the validation of what can be seen from the space. From this data, we are entering, we are assimilating, we are feeding some geoinformation segments. These geoinformation segments answers to some thematics, but after that, without the people after, the geothematics tools are nonsense. So behind the geothematics data, we are providing the users with some information, and with their expertise, they are able to analyze what is provided. There are new tendencies with this kind of scheme. The first one is that the satellite provider, for example, as Thales, are entering the thematics and are entering the way the data are analyzed to provide a feedback through the satellites for them to be able to answer better and better the user needs. And the user, they are coming towards the satellites for them to be able to participate to the specification of the system they are going to use. Here, this scheme is pretty much pretentious, but it tries to map on a scheme where you can find the GSD, I mean the spatial resolution on a horizontal line, and the vertical resolution is for temporal, the vertical line is for temporal resolution. Here I try to map the different applications regarding what kind of data they use. Of course, it's purely informative. So you have some vegetation, coastal water, you have some oceanography, you have meteorology, you are surveillance, security, and disaster management. All these kinds of applications don't have the same needs and don't use the same data. Here in green, I think that it's green, yes. In green, you can see what is provided now. What is provided now is very interesting because we have some data, I don't know, maybe some of you don't know the Copernicus Sentinel program, which is an ESA program, a European program, to provide the users with free and open access data for land, for ocean, for coastal, for ice, for atmosphere. There is 6 different sentinels with different meaning and different specification. I encourage you to go to the ESA website to see the different Sentinel specification. In Thales, we are involved in Sentinel-1, Sentinel-2, and Sentinel-3, as well in Sentinel-4 and 5. So here you see what is available now. In a really close future, I mean in several months, you're going to be able to work with the data that cover the yellow area. These data are coming from the new generation of Meteo satellites, which is Meteo third generation, the successor of Meteo second generation. Yeah, so you could have seen that. Also performed by Thales and OHB. And here, in red, you will see what are the projects that we have in our bags. Here we have some different kind of projects. For example, we have assessed that the coastal area are not well covered. I mean, they are not well covered with respect to what they need. They need some data that cover the visible and near infrared, more precisely than what we can find in the multispectral images now. I mean, with more different channels, with more different colors, more different, the different kind of specification of the color that we are looking at. So these more precise satellites with an accurate vision of the coastal area, which is not the case for the moment. For the moment, either we deal with kilometers satellites or with 100 meters, which is not sufficient for coastal areas. So here we are talking about tens meter spatial resolution satellites. So they are going to be provided in a close future. We hope that it will be 2 or 3 years and not more. And one thing which is interesting also, you can see at the top right of my slide a kind of balloon. This balloon is what we think is very promising with respect to the data that we can provide to the user. It's called Stratobus. Stratobus is not a satellite. Stratobus is a stratospheric platform. This is a stratospheric platform that is put at 20 kilometers high and that stays stationary with respect to the region that they are looking at. These Stratobus have the characteristic of being able to provide in real time data with the quality, with the temporal resolution of a video. You could have several images per minute. So it's really important when you want to monitor a situation, when you want to survey something. For example, yesterday I was in Masdar Institute and we discussed about monitoring oil spill, because the oil spill are a phenomenon that pollute the desalinization complex. So here it's very important to be able to react in minutes. So with this kind of platform, a stratospheric platform, we will be able to provide the users with the data that enable them to survey, to monitor a situation. It could be a pollution, but it could be also some disaster assessment or disaster monitoring. And it's really important because this size of application that needs high spatial resolution data in terms of spatial and temporal resolution are not covered for the moment by the satellites. I've been shortened. Actually, we are going to pass only the 3 next slides because now it's less than 10 minutes, so I'm in a hurry. Okay, so what I will want to focus on now is 3 different themes that are important because they have been reported to us by the users to be important. The first one is the atmosphere. the atmosphere application, which are the air quality, which are the aerosol detection and characterization. For example, for the dust storm and radioactive transfer, and also from the meteorology, the cloud covering mapping, the forecast of solar resource maps, etc. These ones need some geostationary information. So here we are talking about the next generation of meteor satellites, the third generation. They will provide to the users information at, is it okay, Marco, or I am already in a hurry? Okay, fine. Are at 500 meters resolution, which is to see, with respect to what it's now, it's 1 kilometer to 3 kilometers. So we are going to improve here the spatial resolution and the temporal resolution because it's one image every 10 minutes. The second one is the water quality. The water quality deals with algae bloom, fish farm, quality survey, and suspended matter. Here, we will be able to provide data with a really spectral information that enrich so much the data that we will be able to cartography the concentrations of the chlorophyll very well. It's something, for the one who are familiar, it's something like a MODIS, but with better, more bands, 21 bands, and with, in the visible and near infrared, and with better spatial resolution, 300 meters. And the last one, because I don't have much time, is for security and monitoring of a disaster situation, for example. Here we are talking about sensitive site survey, but also disaster assessment and monitoring, both PRC and survey, special event monitoring. And we intimately think that for this kind of special needs, the platform that suits very well is what I've just talked. It's the Stratospheric platform, because it enables to provide data really like a video. What was next, and I won't show you the slides, is that with all this kind of data, we can provide you all the data you need. It's not a problem. We can provide you very much more data than you need, but after that, we have to be able to process them. And it's why in Talis Alenia Space we are also working in the machine learning, because the full chain of value, which is providing the data and being able to extract the information, is important. So after that, and if you are interested, we can talk about it later, we are now processing some operational machine learning algorithm which are able to proceed with this lot of data, this enormous, gigantesque amounts of data that you will have at your disposition really soon. So I thank you for your attention.